Okay, this question that I'm going to go through, it's on the note package that I provided. If you don't have one, blank copies of this note package are on the Google Classroom under the transformation section. This is a good question because it's a very common diploma exam question, and I will for sure have it either on your first quiz or on your exam. The reason why they like giving this question is because there's no graph, and it just really tests your understanding of being able to apply parameters to domain and range. So what it says is it says the function y is equal to f of x has the following domain. So x is less than or equal to 12, greater than or equal to 7. And the range of this function is y is less than or equal to 10, greater than or equal to -1. What is the domain and range of the transformed function? Okay, so essentially what we're doing is it's saying, I'm going to give you a domain, or so I'm going to give you a function, y is equal to f of x. And then I'm going to transform that function to y plus 8 is equal to f of x minus 3. Okay, so you need to be able, and then they're saying if that's the original domain on the original function, after the transformations, what will the new domain and range be? So before we go through the domain and range, let's figure out what the parameters were and then how we're going to apply that. So again, this should be a total review. There's nothing new here, and you should actually be able to attempt this question on your own without even this video. So you need to be able to look at that, and you need to be able to say, okay, that is my k parameter, and k is equal to -8. So the k parameter is your vertical translation. So that would be a vertical translation 8 units down. Then you would go here. This is my h parameter. It is within the function. So my h value, it is not -3. The h value is going to be the opposite of what it looks like. So the h value is 3, and that is a horizontal translation, 3 units right. Okay, then you have to be able to just know, well, which parameter affects domain and which parameter affects range. So the h parameter, it's next to your x. Like I always tell students, that's a big clue. The h parameter is the one that affects your domain. So the h parameter affects our domain. So what we're going to be doing to our domain is to each x coordinate on our domain, we're going to move it 3 units right? So this is our domain, and we're going to move it 3 units right. Then our range is the k parameter is next to your y is your range. So this is going to affect your range. The k value always affects your range. Okay, now, it wants the new domain and range in interval notation. Right now, this is in set notation. So if I was to write this domain in interval notation, this domain would be in interval notation. The smallest x value is -7. The biggest x value is 12. Okay. If I was to do this range in interval notation, so the smallest y value is -1 and the biggest y value is 10. That would be my range. Just to quickly show you before I actually do the new domain and range, what the mapping, remember, is, it is x comma y, and then it's x plus h, y plus k, right? So your domain are your x values, and we're going to add 3 to each of our x values. And our range is our y values, right? And what we're going to do to our range is we are going to add 8 to our range. So my original domain was -7, 12. Those are two x values. So let's write our original domain, -7 to 12. And what's going to happen is I need to each x value add 3. -7 plus 3, 12 plus 3. Therefore, my new domain, -7 plus 3 is -4, and 12 plus 3 is 15. That is my new domain, or my transform domain. My range now, let's go back to what they said my range was. So my range was -1 to 10. And to each y value, I'm going to add 8. -1 plus 8. And sorry, I'm going to subtract 8. That's a mistake I made. 8 units down means -8. So let's try that again. To each of these y values, I need to subtract 8. -1 minus 8, 10 minus 8. My new range, -1 minus 8 is -9, 10 minus 8 is 2. And that would be the domain and range of your transform function.